Number 9 says, what do you notice about the graph of s of d compared to the graph of d of s? What is the relationship between the functions d of s and s of d? So to make it a little bit prettier, I went ahead and graphed these. So I have my two equations in here, and I just did from 0 to 50 on both the x and the y-axis. And I get this right here. Okay, what do you notice about the graphs? What is the relationship between the functions? These graphs are reflections of each other. If I was to graph the line y equals x, these inverses are just reflections over the line y equals x. And whenever the graphs are reflections over the line y equals x, they are inverses. So what do we notice about the graphs? The graphs are reflections over y equals x. And what is the relationship? That they're inverses of each other. Now consider the function d of s is equal to 0.03 s squared over the domain of all real numbers. Okay, so as we were talking about it earlier, we said the domain would be from 0 to infinity because they could never have a negative speed. But now we're just saying, let's just look at the equation. How does the graph change from the graph of d of s? Well, d of s was just the right side of the parabola. Okay, if we were to take the entire equation and not make it specific to our example, then we would have the left side of the parabola. Okay, we would have the left side of the parabola, and that's how it changes. Now, how does changing the domain of d of s change the graph of the inverse of d of s? Okay, well, if I was to reflect this all over the line of y equals x, I'm going to come out with something that looks like this. Okay, the graph of the inverse now is a parabola. We just switch our x and our y-axis, so the graph now changes because before we just started at 0, 0 and went up like this. And now the graph of the inverse also continues on the bottom. Okay, it's a parabola on its side because we're just taking this whole thing and we're shifting it over. Now, is the inverse of d of s a function? And the answer is no. Why is it not a function? Because remember, a function has to pass the vertical line test. Because for every input, for every x value, there can only be one output. And there's two outputs. If I go to x equals 2, there is going to be two different answers. Because basically what we're saying is we're taking d of s, and if we were to find its inverse without restricting the domain, we would switch the x and the y. We would divide both sides by 0.03, and then we would square root both sides. Whenever you square root something, you have to take the positive and the negative. So y would really be equal to positive or negative square root of x over 0.03. So this top part would be if I had positive x divided by 0.03. This bottom part would be if I had negative x divided by 0.03. So I've gone ahead and graphed both of these equations for you. So this parabola right here is d of s, or y is equal to 0.03 s squared. And then if you look, I have this second parabola over here that's tilted over on its side. And this I had to put in as two equations. The first one is positive square root of x divided by 0.03 and negative square root of x divided by 0.03. And as you can see, it's not a function because it does not pass the vertical line test. Now, if we just look at the original graph, okay, the graph of our original function, can we tell if the inverse is going to be a function? Well, you can. Because, let's think about it. In order for it to be a function, for every x, there could only be one y. Well, if they're inverses, that means that that's flipped. So for my original function, every y could only have one x value that correlates with it. If we look at this parabola, for this y value, I have two different x values that will give me that y value. Okay, so that means that when I find its inverse, that y becomes an x value and it is now going to have two y values. So you need to look for graphs that are 1 to 1. Now what does it mean if they're 1 to 1? 1 to 1 means that for every y or output, there is only one x. 1 to 1 is kind of like the opposite of saying that something's a function. In order for it to be a function, for every x, there can only be one y. For it to be 1 to 1, for every y, there can only be one x. Now, a function doesn't have to be 1 to 1, but in order for a function to have an inverse that is also a function, it has to be 1 to 1. And to figure out if something's 1 to 1, you just do the horizontal line test, the opposite of the vertical line test. So remember, in order for something to be a function, it has to pass the vertical line test. In order for something to be 1 to 1, it has to pass the vertical line test. And only 1 to 1 functions will have inverses that are also functions.